Hi folks, welcome back to 5.5. This is Calculus with Mr. Robeson. We are looking at inverse trig integration today. I believe 5.5 is the last section on integral rules. After this we will still have more integrals, but it's like techniques and things like that. So inverse trig function is what we're looking at in this video. So again, we're just working backwards from our derivative rules. So in other words, if we take like the integral of something like this, these will cancel out, and this will go back to something like that. So if we have something besides 1 here, that's okay. We just end up with that a down there. So whatever number is here, we take the square root of it, and that's what ends up going down there. So we have a constant squared minus some sort of variable squared. We need to have the du on the top. So whatever u is, we need to make sure that matches a du on top or on the back here if you want. And we get the inverse sign or arc sign of u over a plus c, nothing out front, unless we did some factoring to get a du to match. All right, with the arctan, this one doesn't have the square root. So remember, the derivative of arctan is just the derivative of the inside, 1 plus the inside squared. So again, we could have some sort of a number here besides just 1. That's fine. We just divide by 1 over that out front, and we divide by that inside of the arctan. All right, and again, this is the one that doesn't have the square root. So if we are adding two guys and we don't have a square root, and we can make them each a perfect square, that's going to be arctan. Arcsecant is the other one. So these are the only three we have to worry about. The other ones we don't really have to deal with. It's just a matter of a negative sign up front. So we always use just these three, and that's it. So the derivative of arcsecant is derivative of the inside over the absolute value of the inside, the square root of the variable squared minus 1. All right, now we could also do this with some other number besides 1, and we just get the 1 over that and over that on the inside here. Or basically just divide everything by a squared. It works out. It's just a bunch of algebra. All right, but we have this variable here, this u, in absolute value or not, and then the du up there. So again, we end up with absolute value here, and we have the 1 over a term in front. So sine does not have the 1 over a, but does have a square root, and secant does have a square root. Tangent has no square root and still has the 1 over a. All right, so let's see. We've got a square root. There's nothing out front. So it is probably arc sine. And we could say a squared and u squared. So then a would be 2 and u would be x. And then du would be dx. It matches. So we don't have to do any sort of fudging to get the factor in there. So this just becomes arc sine of x over 2, u over a plus c. And remember, we could also write this as sine to the negative 1 of x over 2 plus c. This means the same thing as arc sine. Those are equal to each other. All right. Next up. All right, so now we're adding. We have no square roots. Makes me think this might be arctan, and we have an x squared. So this is my a squared, and this is my u squared. So then a must be the square root of this, so that'd be the square root of 2. And u must be the square root of this, so that would be 3x, because 3x squared would be, quantity squared would be 9x squared. So now we got to match du equals 3 dx. So we need a 3, and we put a 1/3 out front. So we get 1/3, and then I believe with the arctan there was a 1 over a, so 1 over the square root of 2, arctan of u, which is 3x, over a, which is the square root of 2, plus c. And there we go. If we want to combine this out front and say 1 over 3 root 2, that's fine. We can do that. All right, last one here. All right, so we've got the square root. We've got an x in front, and we've got the variable minus the constant. So that's arcsecant. So that means this guy is my u squared, and this is my a squared. So a must be 3. And u must be 2x. Right? Square root of 4 is 2. Square root of x squared is 2, is x. Du would then be 2 dx. So we need a 2 here, and we'll put a 1/2 out front. All right, the rest of this, well, does it match or does it not match? Let's go back and take a look. All right, so we need to have u exactly in front of this. All right, so let's go back now and look at it. u was 2x. Do we have 2x out here? We don't. But we can take this 1/2, instead of putting out front, we can just put the 2 there. And now we've got it. All right, so that was kind of a sneaky little move. We put the 2 on top, the 2 on bottom. They technically cancel each other out, but just leave them there. Because now we've got that it matches. This is my du. This is u squared minus a squared, and this is the u in front of the square root. So this is 1 over a, so 1 over 3 arcsecant of u over a. And that u on top is in the absolute value. So I'm going to write it like that, plus c. All right, so the arcsecant is tricky, especially when I leave out a c in the word arc. There we go. It was the arcsecant. It's the pirate version of secant. All right. Let's try some trickier ones here. So how about this one? So we've got a square root here. We've got a couple options where we can do this one. It says try using total substitution, but I think I can do it differently. So we've got the variable here minus a constant. So we can say that this is e to the x squared like that minus 1 squared. All right, e to the 2x, same thing as e to the x quantity squared. So then our u here would be e to the x. Our a here would be 1. Du would be e to the x dx. So we're missing e to the x. All right, but we also definitely need to cancel that out. So we'll put another e to the x down there to cancel it out. We can do that. It's kind of a weird thing to do, but we can do that. And now we've got our u here. We've got our du up here, u squared minus 1. So this becomes exactly 1 over a, so 1 over 1, arcsecant, the absolute value of u, so the absolute value of e to the x, over a, plus c. Now we don't need most of these, so 1 over 1 is 1, over 1 is just 1, absolute value e to the x is e to the x. So we're just going to get that this is the arcsecant of e to the x, plus c. And there's our answer. Neat, so I didn't have to do total substitution. I think I did total substitution last year. And I think it was a lot of work. All right, but arcsecant works a lot better there. So we'll stick with that. All right, let's take a look at this one. All right, so I've got, looks like a squared minus u squared happening there. So my a would be 2 and my u would be x. And du would be dx. All right, so we look at now and we've got all this junk on the top. Well, I'm not sure what we can do with all that. There's no way we can make just dx out of just that. All right, we wouldn't be able to get rid of that. So what we can do is we can split this up. So instead of trying to do that, we'll stop and we'll say, all right, well, other option is we could set this whole thing here equal to u, and then du would be negative 2x dx, and we'd just be doing regular old substitution instead of the inverse trig functions. But again, we don't have that on top. But I notice if I have just an x on top, like just this guy, I can make that. I can put in a negative 2. And then I can leave this guy as his own separate integral, and we can do the arc-trig with that one. So I'm going to say that this is x over square root of 4 minus x squared dx plus 2 times the integral of, we'll just say dx over square root of 4 minus x squared. So this one is going to be arc sine, and this one is going to just be regular old substitution. All right, and I already done my substitution for u for this one right here. So I just need a negative 2 and a negative 1/2. And for this one, this is exactly that. So this is exactly there. So this first integral is going to be negative 1/2 the integral of, so all this became my du, and this is the square root of u on the bottom. So u to the negative 1/2 du. This one, let's see, we got the 2 out front. And this is straight up arc sine. So it's arc sine. Arc sine didn't have the 1 over a in front. The other ones did. Of u, which was x, over a, which is 2, plus c. Now we just got to do this guy. So negative 1/2 u to the 1/2 over 1/2. And these 1/2s are going to cancel. We still have the negative sign though. So we're getting negative the square root of u. And u for this guy is right here. So it's going to be 4 minus x squared plus 2 arc sine x over 2 plus c. All right, so the trick here is if we're adding or subtracting two terms on the top, we can break it up into two separate integrals. So we got like one integral here. We can do that with substitution. The other integral here we can do using the Arc-Trig. All right, so that's Arc-Trig. I'm sure that was fun. All right, don't worry, we don't have to evaluate Arc-Trig. We just got to be able to integrate it.